Well, here we are, ready to start our FRQ review. We've learned all the chemistry that you need for AP Chemistry, so let's use those skills and some extra tips on answering FRQs. We'll start with question 1. And question 1, as with the free response questions, is a group that has 10 points per problem. Your free response questions, they account for 50% of the points on the AP exam, and you've got a lot of time, an hour and 45 minutes. And in that test booklet, you'll have a periodic table and, of course, the equation constants, and you can use a calculator. The FRQs are broken into questions 1, 2, and 3, which will take about 22 minutes per question. There will be definitely 10 points for each one of these problems. And then questions 4 through 7, those will only have 4 points per problem, and you shouldn't take about more than 9 minutes per question. Our goal is to get 70% or better for a 5, 55% or better for a 4 roughly. Don't forget that only 10 students out of 160,000 get a perfect score on these FRQs, so it's challenging. Be sure to download and read my tips on free response questions. I think you'll find them very helpful. This is the first page. Let me just go to this so you've got some idea of what the FRQ booklet looks like. Naturally, you'll have that first page where you give the instructions, where you're supposed to show your work and the rest, but we'll go over that. And typically, as I said, the first 3 questions are longer ones. They're either 3 or sometimes even 5 pages long. There's plenty of spaces in between the prompts for you to answer those questions. You should not ask for extra sheets of paper. If you do, first of all, you're going to be taking too much time and you're doing too much to answer these. Don't ask for extra paper, even though theoretically you can. So here's like question 1. Here is the sequence for question 2 and 3. Now they say read over an entire problem before you actually start to answer it, and that's really not practical with the way this is set up now. Skim it over quickly to see, okay, this is an easy part, this is a harder part, this one I'm going to be worried about. But just skim lightly and then focus on 1 to 2 pages at the very most, because you'll have this booklet open and you'll see the first 2 pages in front of you. So that is relatively easy to read. And the way they designed the exam is so that you don't have to flip back and forth often. Questions 4, 5, 6, and 7, you can see here, are typically 1 to 2 pages because there's only 4 points for each one of these. The weight of the points is about the same as an MC. That's sort of an early introduction. I'll give you more tips as we go through the review. So let's go back to question number 1 as an FRQ and start answering it. So this is on 1 page, and we're going to go do 1 page at a time. They give us a prompt. Here's calcium oxide to be used to heat water quickly. It's got an exothermic reaction when you dump it in water. When placed in water, calcium oxide reacts as shown by the equation above. A student wants to design a heating pad that would heat a 150 gram sample of water from 25 degrees to 60. So we're heating water. So calculate the amount of heat in joules that the water must absorb for its temperature to change by this amount. And they give you the heat capacity of water. Now, the heat capacity equation and the calorimetry equation that you have, and there's always a calorimetry question on the AP exam, is one that you can look up on the equation sheet, but really you should know it. Q is the amount of heat, the joules, the mass of whatever is being heated. C is the specific heat capacity, and then we've got a change in temperature, which can be either in kelvins or degrees Celsius typically. In this case, they give us degrees Celsius for a specific heat, but kelvins would do the same thing. We've got everything we need to calculate the heat. Q is the heat. We've got a mass of water. We've got a change in temperature. We've got a specific heat. So it's just a matter of putting those things in a calculator. Now, you've got to show your work. When I talk to readers, they say they're surprised with how many students just use their calculator and don't show their work. They get the right answer, but they can't be given the points for that. They'll say typically a student will have all the answers right, but only gets 2 or 3 points because they didn't show the work that was done. Now, it doesn't have to be beautiful and exact like this. You just have to show the numbers that you're multiplying when you're doing a calculation or dividing or square rooting. Here's our calculator. I'm starting with a clean slate, just 150. Anything that you type into your calculator, write down on the paper. It's got a couple of reasons for that. One is to show your work so you get the points. The other is if you go back to the problem, if you have some extra time, you can review what you've done. This is for you too, not just the grader. And then, of course, we've got our equation. Our mass is 150 grams of water. Now, if you've got a solution, you'd include the mass of the solid in there, but this is just water we're heating. We've got the standard specific heat, 4.18 joules per gram degree Celsius. The grams will cancel, and that will just give us joules because we're multiplying by this 60 minus 25. Got my parentheses. I'm going to double check. 150 grams. Yes, 4.18 specific. Oh, there's an error. Let me go back and change that to an 8. 4.18. It's worth checking the numbers over because if you get the answer wrong, that's it. Too bad. So I spent the time. I've got things right. 150, 4.18, 60 minus 25 degrees Celsius. We've got quite a few joules. The number of joules is 21,945 joules. Now, typically, we look at this heat of a reaction and such. I would change that because it's such a large number of joules into kilojoules. I'd have my calculator there right away and divide by 1,000. You want to keep the numbers simple. 21.9 kilojoules would be an excellent answer for this. And here we are, 21.9 kilojoules. Just showing these numbers, you don't have to show the units up here, but you have to show the units for your answer. Now, one of the things that you really should get in the habit of is when you get an answer, go back to the question and see if you really answered the question that was being asked. That's the other thing that graders say, that very often students aren't answering the question. Let me check. Calculate the amount of heat in joules that a water must absorb for temperature change by this amount. We've got it in joules. If you gave it in kilojoules, you'd be fine too. 21,900. 3 significant digits is all you need. It sort of makes sense. 21,000 joules. We're heating 100 grams of water times 4 times about 20. Yeah, this is going to be a large number. In terms of grading, the graders would give you 1 point for the correct answer. 1 point, 1 out of 10. Next, II. For A, calculate the minimum mass that a student would need to use in order to cause this temperature change. We've got the calcium oxide causing the change. And they tell us here that for this reaction, mole of reaction, it's 63.7 kilojoules for every mole. That's for moles of 1 calcium oxide. So I'm going to need 21.9 kilojoules, and a mole will give me 63. So I know I need less than a mole. So I'd go back and say, okay, I need that heat, 21.9 kilojoules. I've changed it into kilojoules so it matches my delta H of reaction. And I know that 1 mole will give me 63.7 kilojoules. So if I divide 21.9 by 63, about a third, all I'll need will be about a third of a mole of calcium oxide. Now they want the mass. Now we've got the moles, so we're going to have to change now these moles into grams. But let me get my calculator out and do the calculation. Oh, I've got my 29.45 in there. I'm going to divide it right now by the 63.7. Don't clear your calculator every time you do something. You can do a series of calculations, and in this case, it's easier because I don't have to retype a number in. I don't have to make an error by accidentally typing in the wrong number. And that's right, it's about a third of a mole of calcium oxide. Now we've got moles, we've got to change moles into grams. Well, they didn't give us the molar mass of calcium oxide. We're going to have to look that up. On the AP exam, you would flip forward to the front page where there is the periodic table. Here's our periodic table. Remember that was calcium oxide, and you'd want to find the molar mass of it. I'd remember that calcium has got a molar mass of 40, and you know oxygen has 16, so this is going to be about 56. But let's make sure we get this to the right number of significant digits. So I'll pull my calculator out, and I've got my, if I change grams to moles, all I've got to do is multiply. So I'm going to multiply this times the grams per mole, which would be, I'll do it to 3 significant digits. So I'll use everything there. 40.08 plus 16. Oxygen is 16.00. So nice to have it, that easy number. Let me double check. Grams to moles. I've got this many moles and this many grams per mole. Come up with my answer of 19.3 grams. Now I put this in my calculator. You've got to make sure that you put it on your paper. Don't just put the answer down. Put 21.9 divided by 63 times our 56.08, or you could have used the 40.08 plus 16. Again, this is done nicely to show all the units. And if you need those units to help you using this factor label, by all means use it. But just the numbers itself would be enough. So here we've got our answer. I'm going to double check 19.3, 19.3. Just needed 3 significant digits. There were 3 here, and of course there are only 3 here. So that's the way this would be graded. They say you get 1 point for the moles. Now if you'd set it up for the division to get the moles, but didn't actually write the moles down, that's fine. If you had a 21.9 divided by 63.7 to get the moles of calcium oxide, even though you didn't write it down and had this long factor label, you would get the point for that. That's why they say can be implicit. And then you get 1 point earned for the correct mass. Now let me just double check to make sure, which I should have done as soon as I put that 19.3 down. Did I answer the question? Mass of calcium oxide. Yes, I got grams. We needed about 1/3 of a mole, and 1/3 of 60, it's about 20. This makes beautiful sense, and we've answered the question. Well, this is our first try at a FRQ. We've got some important tips here. Check to make sure you put the answer in. Show your work, show your work, show your work. And make sure your answer is reasonable. That's our first question. This is what the question would look like on an actual FRQ. You'd have plenty of space to answer these, and you'd want to take about 6 minutes to get all 3 points for this FRQ. Of course, that's the paper version. Now for the real version. This is a pretty dramatic reaction, taking cold water and adding it to calcium oxide to get enough heat to boil water. This is MEL Science doing it. And they've got about 500 grams worth of calcium oxide and some cold water, and it gets hot enough to cook the egg that's been put in it. This is sort of a classic demonstration that is fun to watch, but I wouldn't want to do it because it is pretty messy.